question 4 is a walk in the park. They're testing our knowledge of limit laws. If you're not good at limit laws, just go watch them first and then come here. Now we know our limit laws, and now we have been given 3 limits that we're going to be using. Limit as x approaches a of f of x being -3, and they've given us another one, which is the limit as x approaches a of g of x is 0, and the last one is that the limit as x approaches a of h of x is equal to 8. So we have these 3 limits that we know already. Now we are supposed to use that and the limit laws to solve this. So let's solve limit as x goes to a of, in brackets, f of x plus h of x. So they said we must solve, and they said if it does not exist, we should explain. So this is not even a problem. Let's put it. This is going to be equal to, we know that there are things that make the limit not to exist. Number 1 is if the denominator is becoming 0 and you have no way of fixing it. And number 2 is if the left, and if a limit comes and you have the left and right hand limit and they are not the same. But here you're not going to ever meet a situation like that where you have the left and right hand limit, because left and right hand limits, we meet them, especially when we are talking about modulus, okay? Modulus things. And also we meet it when we are talking about not only modulus, and the piecewise functions, of course. So now we can solve these. Let's quickly solve it and let's see how it goes. So here we know that if I'm getting limits of 2 things that are adding, I can separate the limits and add them separately. So I can say this is going to be equal to, I'll get the limit of the first part and I'll add the limit of the second. So it's going to be the limit as x goes to a of f of x plus the limit as x goes to a of h of x. Now we know the limits, we know them. What is the limit as x goes to a of f of x? We have it. See, this is going to be, the limit as x goes to f of x is -3. So it's going to be -3 plus, once the limit as x goes to h of x, it's 8. So it's going to be -3 plus 8. This is what we're going to have, right? And this is going to be -3 plus 8, you punch, and you're going to get 5. So this is going to be the number 1. And we can do number 2 as well, part B. Part B is going to be the limit as x goes to a, okay, of, in brackets, g of x minus f of x. Okay, so now we know that limit law says if you have the limit of 2 things subtracting, it is going to be the subtraction of the 2 limits. So it's going to be, we separate it. We'll get the limit of this and then we subtract the limit of the other. So it's going to be the limit as x goes to a, okay, because it's the limit as x goes to a, it's there here, of g of x, all right? Then we say minus the limit as x goes to a of f of x. And what is the limit as x goes to a of g of x? We have it here. Limit as x goes to a of g of x is 0. And then the other one was the limit as x goes to a of f of x, which is -3. So it becomes 0 minus, the other one is -3. Be careful. Watch out for these negative signs, because this is going to trick you. There's a minus, then f of the limit is a -3, and it comes after this minus. So that is what we do. 0 minus -3 is like 0 plus 3, and your solution will be 3. This is going to be the solution. And here we have our A and B. We'll do the others in the next video. Goodbye for now.